Okay, now let us see second half of the unit. Now, when you want to calculate the pH value of very diluted solutions, what can be done? Okay, so for that there is some treatment, and for that one equation is used for calculating pH value of very diluted solution. Okay, so derivation is not expected now. So using this equation, H3O plus ion concentration, okay, so that is H plus ion concentration you can determine by knowing concentration of the undissociated acid plus uh, minus square root of concentration square of that undissociated acid plus 4 into ionic product of water divided by 2. Okay, so using this equation you can calculate pH value of very diluted acid solution. Like if you take 10 raised to minus 7 and if you use simple formula of pH is equals to negative log to the base 10 of concentration of H plus ion, here in this example you will get pH value will be 7, okay, using regular equation, but you know HCl is acid, so it will have some acidic pH value. So exact concentration of this is very diluted solution, you can see 10 raised to minus 7 is there. So for that you can calculate pH value. Okay, so for this example you will find it is 6.79, though it is near to 7 but not exactly 7. Then we have seen concept of buffers. Buffers क्या है? These are the solutions which resist sudden change in pH value. Okay, so remember the composition of acidic buffer solution, remember the composition of basic buffer solution and examples under each. Then we have seen Henderson's equation for calculating pH value of acidic as well as basic solutions, basic buffer solutions. Okay, so Henderson's equation you will see and simple calculations from that. Then at the end we have seen buffer capacity. Okay, buffer capacity क्या है? The magnitude of buffer action of given buffer to change pH on addition of strong acid or strong base is called as buffer capacity beta, okay, of any buffer solution. So what will happen to pH when a small amount of acid or base is added to the buffer solution, whether there will be change or not? Okay, so that indicates the buffer capacity. Okay, so this is how buffer capacity is calculated. Okay, so this is all about the ionic equilibria unit. In this unit particularly focus on electrolyte types of electrolytes, strong and weak, acids and bases. Remember example. Then alpha, that is dissociation, degree of dissociation, then dissociation constant, factors affecting degree of dissociation, followed by common ion effect details, calculations based on that. Then pH, concept of pH, POH, pH scale, then calculation of pH value for simple examples, then examples for buffer solutions, acidic, basic, okay, Henderson's equation, and then the buffer capacity. Okay, so that is all about part 1 of the unit 1 of paper 2. Then another unit in this is molecular spectroscopy. Okay, we have seen what is spectroscopy. It is branch of science which deals with interaction of light with matter. Okay, now what is light? Light is electromagnetic wave. We know it is not simply the electric component or magnetic component. It is combination of electric and magnetic component which are perpendicular to each other. So light is having wave nature and also particle nature. Okay, wave particle duality is explained with the de Broglie equation. So electromagnetic radiation, it is electromagnetic. Light is simply electromagnetic radiation. So both components are there, electric component are there, magnetic component are there which are perpendicular to the propagation of wave, and it is having wave as well as particle nature. Then we have seen different characteristics of electromagnetic radiation, and like a definition of wavelength, we have seen distance between successive crest and trough is called as wavelength. It is denoted by lambda and having unit in terms, since it is length, it can be meter, millimeter, micrometer, nanometer, and stuff, etc. So depending on length of wavelength, its unit will be derived. Okay, so just remember it is just distance between successive crest and trough. So if this is your wave, then you can take distance between either crest or trough means area. So this will be distance between successive crest, or this is crest, bottom one is trough. Okay, so that will be your wavelength of light, lambda. Distance is calculated in uh, length unit. Then frequency, it is what? It is number of waves passing through certain point in 1 second. Okay, so just imagine one point, from that how many waves are passing in 1 second are the frequencies. So it is denoted by nu. Okay, it is nu. It is expressed in hertz. Hertz simply क्या है? It is cycles per second. Okay, hertz is cycles per second. So depending on how many cycles are there, so it can be kilohertz, megahertz, and so on. Okay. Then wave number क्या है? Wave number is number of waves per centimeter or per meter in the vacuum. Okay, so in particular area, particular space, 1 meter or 1 centimeter, how many waves are there in the vacuum is the wave number. So usually frequency, instead of expressing it up in terms of frequency, it is usually expressed in terms of wave number. It is denoted by nu bar, and it is calculated by just taking reciprocal of wavelength lambda. Then velocity of light, it is 3 into 10 raised to 8 meters per second. Okay, so unit कौन सा है वो देखो. It is 10 raised to 8 meters per second. Then in all, if you want to remember all the equations together, nu bar is simply calculated by taking reciprocal of 1 upon lambda will be equal to nu upon c, or nu is equal to nu bar into c. Okay, so this is just interconversion of different units. Okay, so if you are interested in any particular unit, you can of course simplify it. So simple numericals will be there. So calculation of wave number. So any wavelength will be given to you, simple wavelength, so that without calci also you can calculate. So that will be the just reciprocal of that. 1 upon 5 रहेगा, तो that will be, yes, so that will be wave number. So convert the unit. Lambda अगर नैनोमीटर में रहेगा तो unit of wave number will be nanometer inverse. So energy के लिए all in one equations, remember E is equals to h nu. Okay, from this equation what you will understand is E is proportional to nu. The proportionality is direct proportion. Okay, E is directly proportional to nu. Nu is frequency. Okay, then E is inversely proportional to lambda, and E is again directly proportional to nu bar. So these three are variables. Nu is frequency, nu bar is wave number, and lambda is wavelength. Okay, so of which energy is directly proportional to frequency and directly proportional to wave number. Energy is inversely proportional to wavelength. And this proportionality constant is called as Planck's constant. Okay, proportionality constant is called as Planck's constant, and C is velocity of light. H is Planck's constant. Okay, then we have seen electromagnetic spectrum and different regions in it. So remember energy of every region, name of region and energy of region, how energy is high, how energy is low. Okay, variation of energy. Cosmic rays, gamma rays are highly energetic. they will have less wavelength. Okay, wavelength is lower because energy is inversely proportional. जो side में higher energy रहेगा, you can see their wavelengths are very small. They are in nanometer, 10 raised to minus 9 meters, whereas for IR it starts with millimeters. Then in microwave it ranges in meters. In radio waves it ranges in kilometers. Okay, so this is how wavelength is increasing towards lower energy values of radiation. So remember this type. Then we have seen each and every radiation and its details. Okay, so gamma radiations are usually, or cosmic radiations we call. Okay, gamma radiations are emitted during the disintegration of radioactive nuclei. Okay, when some radioactive nuclei disintegrates to form new stable nuclei. Okay, that time gamma radiations are emitted from that unstable radioactive nuclei. And just go through uses of each radiation. Okay, that day we have discussed all the uses, so go through for every radiation. Just remember its wavelength. Okay, wavelength, where it lies in the electromagnetic spectrum, and uses of it. Then followed by this, we have seen the different interactions of electromagnetic radiation. Okay, we have seen 4 5 phenomenon. Absorption of radiation. Okay, how absorption is expressed, like when some substance absorbs the energy with the h nu amount of energy. Okay, photon, then it absorbs energy. When it absorbs energy, it excites from ground state to the excited state. Okay, so this phenomenon happens when light is absorbed by the substance. Then emission क्या है? Emission is reverse process of absorption, where some species from the excited state, okay, already it has gone from the ground state by absorbing h new amount of energy. Okay, by absorbing h new amount of energy, it has gone from ground state to excited state. Now for excited state we are showing asterisk, which is highly unstable species. Now it will come back to ground state by two processes, by either emitting another radiation of similar kind of energy h nu dash, or by phonon. Okay, so this is emission process. Okay, this is emission process, this is absorption process. So remember this. Scattering kya hai? When your solution is not clearly transparent but contains some particles. Okay, we have seen here different phenomenon. So if this is your sample, okay, in sample if there are different number of atoms are present, then when a light passes on this, scattering of light take place. Scattering take place only when intensity of light, the wavelength of light is smaller as compared to the particle on which it strikes. So if the scattered angle is 90, around 90 degree, this type of technique is called as nephelometry N. And if the particle is smaller, the measurements are taken at 180 degree. That type of technique is called as turbidometry T. Okay, so this is your incidence radiation I0. Okay, I0 radiation after scattering, the intensity, if it is measured at angle 90 degree, that technique will be nephelometry. If intensity is measured at 180 degree angle, okay, the straight path, that will be turbidometric technique. Okay, that we have seen. Then fluorescence is concept. Okay, where uh, when your system undergoes excitation, okay, then there is intersystem crossing take place, and while coming back it shows some emission of light. So in fluorescence also there are two types. Delayed fluorescence we call phosphorescence. So even if we cut source of radiation, then also it emits light, so that is delayed fluorescence. Okay, then different kinds of molecular transitions we have seen. Okay, three molecular transitions we have seen: rotational vibration, rotational transitions, vibrational transitions, and electronic transition. For that we we have drawn one image showing all in one. So just I will repeat that image over here. So this is your uh, ground state and excited state. From ground state to excited state, if transition is taking place, okay, this is the ground state, this is the excited state, then this type of transition is called as electronic transition. Okay, electronic transition. And for this, amount of energy required is UV visible light. Okay, UV visible light is required for electronic transition. But now, if absorbed photon is having less energy, then electron will not jump from ground state to excited state. Okay, it can jump only from one ground state to some another higher state. Okay, this state is the vibrational state. Okay, vibrational state. So for this molecule, if absorbs IR light, okay, vibrational states are uh, molecule can jump from one vibrational state to another vibrational state. Okay, for electronic transition, you require UV visible light. And then for a molecule which absorbs still very little amount of energy, okay, these are different vibrational energy levels in the molecule. Now if very low amount of energy is given, okay, molecule can jump very little distance. Okay, this type of levels are the rotational levels present in the molecule. Okay, so these are rotational energy levels present in the molecule, for which microwaves, okay, microwaves are enough. Okay, so when principle of microwave oven, there is rotation of molecule take place, and because of that transitions, okay, we can cook food using microwave oven. Okay, so these are three different energy transitions that are associated with absorption of light. So for ground state to excited state, this is electronic transition. For that you require UV or visible light. For vibrational transitions you require IR light. For rotational transitions you require microwave radiations. Okay, so details of every transition is given here. Okay, so for rotational transitions, remember molecule must possess permanent dipole moment. Okay, जो molecule में permanent dipole moment है वो. तो for preparing types of transition, just prepare for which molecules can show this type of transitions, and then selection rule for given transition delta J is equals to plus minus 1 is selection rule for rotational transition. And then the energy gap. ओके, एनर्जी गैप रोटेशनल के लिए बहुत छोटा सा एनर्जी गैप था, दैट इज 0.005 इलेक्ट्रॉन वोल्ट. then higher energy transitions from rotational are vibrational one. Okay, for that condition is molecule must possess change in dipole moment. Okay, so polarizability is there. So molecule, if it initially it is not having any dipole moment, but when you place it in IR light, okay, it should change dipole moment. Like CO2 is best example for this. So CO2 initially is not having dipole moment, but once you keep it in IR light, it shows dipole. Okay, so uh, this is condition for molecule. Then selection rule is delta nu is equals to plus minus 1, and energy now little greater than rotational energy, it is 0.1 electron volt. Okay, then for electronic transition you will see selection rule from ground state to excited state or excited state to ground state. They require higher amount of energy, 5 electron volt simply. So on this energy level diagram also you can remember where we have drawn. So this energy gap is very small. Okay, this is 0.005 electron volt, right? This IR is little higher. This is 0.1 electron volt. Okay, it is 0.1 electron volt, and this electronic transitions are this gap is very high. This is 5 electron volt. Okay, so you can compare how much amount of energy is required for each transition. Remember the selection rule. Okay, remember selection rule, it is plus minus 1 everywhere. So these points you need to remember in case of molecular spectroscopy. Okay, so in molecular spectroscopy, remember properties of electromagnetic spectrum. Basically, light is what? It is electromagnetic radiation having electric component as well as magnetic component. Remember each region of electromagnetic radiation, then applications of electromagnetic radiation, different selection rules of different transitions. Okay, then in ionic equilibria, remember electrolytes, strong, weak, degree of dissociation, etc. factors affecting, and some numericals, buffers. Okay, pH के ऊपर के numericals, pH scale, everything. Okay, with this, I hope the concept is very clear to you all. So all the best for your paper 2 examination. Yes. Bye bye. Take care. Have a nice time.